Hi, welcome to our IT.talk 2020.
Hi, welcome to our IT.talk 2020. Hi, welcome to our IT.talk 2020. Hi, welcome to our IT.talk 2020. Hi, welcome.
My name is Gwen, and it's my pleasure and privilege to moderate this event. Let's see what's going to happen today. We're going to have a few talks about interesting topics in IT. We're held by company representatives. Each talk is going to take about 20 minutes, and then afterwards we're going to have a Q&A for about 10 minutes. For the questions, I would ask you to write them in the chat, and behind the scenes we're going to collect them, and then we're going to have them afterwards for the Q&A. So let's see. After the talks, we're going to have some private sessions with the speakers. Okay. We're going to have some private sessions with the speakers, and the links are going to be linked in the website. So if you're ready for networking, trying to get to know them, stay tuned for after the talks. So what are we expecting today? We will discuss design choices of a cloud-native database. We will try to understand the lack of transparency in AI and its explainability problem. We will take a look at how shopping centers and stores are involving technology to create a digital customer experience, and we will learn how increasing data can lead to solving new human and economic problems. So without further ado, let me introduce you to Anna Hitt. Anna Hitt works at the AIT for the data science and as a data scientist for the digital safety and security department. And she will discuss the expectations and state-of-the-art approaches used to interpret models in AI, trying to work against the disadvantage of its lack of transparency. Enjoy.
Thank you very much for the nice introduction. Hi, everybody. I hope you had a nice day and are staying safe wherever you are. Today, I would like to talk about what explainable AI is and why do we need this research domain, research field, and what are the challenges in this domain. Also, I would like to give you a little bit of a background about how these techniques work and actually in what projects at AIT we incorporate these methods. But before I start the talk, I wanted to ask you if you know the difference between explanation and interpretation. So I guess I won't be able to see your answers, but the difference between explanation and interpretation is that explanation is just fact that tells us why something happened, and interpretation is basically this particular way that we got to this fact. So remember this because I'm gonna tell you why I pointed this out in the next couple of slides. AI systems, also known as machine learning system, is becoming increasingly present in different domains and applications and becoming increasingly capable of different tasks. But these systems act as a black box and they are missing explainability. What does it mean? That means that these systems are often very much complex and the human expert cannot explain why the system made a specific decision. And that is why the field of interpretable machine learning exists, and this is what we're actually focusing at. This field is also known as explainable artificial intelligence and is basically a set of iterative processes that goes over time. We get the input, we process the input, do some engineering and analyze the data. We build a predictive model on this input and try to make this model as transparent as possible. What does it mean? It means that we try to look into the model, also the output, to try to justify when does the model fail, when does it succeed, and also why did it make a specific decision, and if we can in general trust the model. So trust is a very generic term. It means that we need to look exactly what the data was learning. And this issue was addressed by Ribeiro in his paper, where he introduced LIME. I'm going to explain it in the next couple of slides. They intentionally trained a classifier which was supposed to say if an image is an image of a husky or a wolf. And the classifier had a high accuracy. When they investigated the feature, they noticed that the classifier actually never learned the features of a husky or a wolf, it just learned the background. So when they looked at the misclassification samples and they noticed that huskies were classified as wolves, it was only because there was snow in the background. And this is an example of a classifier that we do not want to use in critical domains. So back to the explainability and interpretability. Why did I point this out? Because as you notice, I was using these two terms interchangeably because in the community, this is basically a term that it's used also interchangeably, but in machine learning community, it is more often interpretability that is used. But in generic term, explainability is basically telling us why something happened, why did the model fail, and interpretability basically focus at the model. So if the model is easily understandable by the human, it's highly interpretable, and if not, then it's less interpretable. Now that we talked about the terminology, I would like to also show you what is out there in industrial awareness. What does it mean? Since 3 or 4 years, there has been a lot of awareness. Why do we need interpretability in machine learning? Why does the model need to be transparent? And also the problems when the model is not transparent, because there has been some decisions that have been made in very, very critical domain and nobody could explain it. And there were some people who basically got suffered through those decisions. And that is why there has been an awareness raised, and companies such as Google immediately in 2017 released Google Vizier, which is a platform that you could basically try to make your model as transparent as possible by looking through your model's internal or the outputs of the model and justify them. Then in 2019, there has been a lot of other platforms which have been released, such as IBM, AI OpenScale, such as FICO for toolkit for credit scoring, and Uber Manifold. These platforms, some of them are for any general, any domain, and some of them are just focusing for specific domains such as financial and healthcare services or credit scoring. And 2020, of course, there has been more work and research done, but I just want to point out packages which are open source and available for Python, such as Alibi by Sheldon, and such as INTERPRETABILITY under a Microsoft license, and also DALX, which is basically developed by MI2 Data Lab, by Warsaw University for R. And there's also another package called IML, by Christoph Molnar, and is also used for R programming. So there are so many tools out there now, and they really do try to bring transparency into the algorithm. But how do they work, and why do we need to research further? So the research should not stop here just because we have some tools. And that is why we should look at the studies that are basically done in this field. The interpretability studies are grouped into two. The first one is the model specific, and is through examination of the prediction results by looking at the internal process of algorithms. It can also be part of intrinsic interpretable models by answering the question of how does the model work. There's also the other studies which are model agnostic, and they focus on prediction, interpretation, and justification. So they basically produce explanation of prediction outcomes. And that is why they're model agnostic, because you need to have a trained model with a training data set, and they also call this post-hoc interpretability to tell you, basically to show you what can the model tell us. Each of these studies provide or use different methods. And for model specific, for example, we are talking about intrinsic interpretable models. So these models have to be intrinsically understandable by human, such as linear regression, where we look at the coefficients of the linear regression. And if you are looking at model-specific approaches, they provide us with feature summary, which is a plot telling us the influence of the features on the prediction outcome. And also we can use target models where we use interpretable models such as decision tree to estimate the decision boundary of a black box model. So these techniques that we are using provide us with two scopes of explanation. They are either global explanation or local. What does it mean exactly? When a technique gives us a global explanation, that means with respect to the train set and the train model, it tells us what would be the decision of the model for all the outcome of the unseen data. And for local explanation, we just take one sample and have explanations for that one sample. An example of a global explanation, we have, for example, partial dependence plots, we have accumulated local effect, we have feature interaction, and for local explanations, we have line, we have Shapley values, we have counterfactual explanations, and there are also some approaches which provide us with both scope of explanation, such as feature importance, individual conditional expectation, and SHOP. So I just named 9 different approaches, and because we do not have enough time, I would go through a couple of them which are more popular, such as partial dependence plot, accumulated local effect, and line. So what is a partial dependent plot? A partial dependent plot basically gives us a feature summary and tells us the influence of a feature on the prediction outcome. How does it work? We need to have a trained model. We need to have a training set, and it basically just freezes, and we just have to also determine what is our target feature. So it freezes that target features value for each instance, and then changes the value of other features randomly in order to estimate what is the influence of that target feature on the prediction output. There is a problem with this approach, and that is that it doesn't take the linear interaction of the features into account. And that is why there's another approach called accumulated local effect, where it's very similar to partial dependence, but for each random value that we give to the other features, we have to have a lower and upper boundary, and the value that we choose has to fall into this boundary. And that is why it also takes the linear interaction between the features into account. That doesn't mean that partial dependence plots are not useful. It's just that we need to know when to use partial dependence and when to use A, or what sort of a data set we're using it. And finally, the last method I wanted to talk about is called local interpretable model agnostic explanation, introduced by Marco Ribeiro in 2016. They have a very nice graphic in their website, and I'm going to use that also here to explain how LIME exactly works. So imagine a typical binary classification. We feed a model that can basically distinguish perfectly the difference and what sample belongs to what classes. And then we pick a sample, and that is where LIME comes into the picture. The black line is our black box model, and the yellow dot is the sample that we chose. Now we want to provide an explanation for that one sample. What does it do? Basically, with respect to this point, it gives some weights to the surrounding of this point, and use this weight as the initial weight of another classifier, and fit the classifier to locally explain the decision boundary of the black box. So as you can see here, it can be pretty much accurate because it actually really sees the decision boundary of the black box model. For us in our group at AIT, we need to use these explainability approaches, these interpretability approaches to provide explanations why the model, for example, predicted something, and also when did it fail, why did it fail, how can we actually improve our model. We use it in different projects such as fake unline detection, where we basically look at the internal structure of the code. We use for fake news detection, where basically it tells us what kind of a word in a sentence, in a document, was the model focusing on to say that this is a fake news or not. I've used it for object detection and automated driving to tell, for example, why did the model detect this specific object, what was the most focus, and why the model says that we need to drive left or right, and also for predictive maintenance. Since my topic is predictive maintenance and I apply explainability on predictive maintenance, I would like to go a little bit deeper and tell you what exactly that is. So, a little bit of a background for those of you who do not know what predictive maintenance is. Imagine you have a car and you're driving with your car. After some point, you notice that the car makes weird sounds. And then you just don't pay attention to it because it's working. And after some time, you notice that, okay, I have problems starting the car, but it is still starting sometimes and I can drive with it. And then still you don't go to a service to maintain your car. And then it goes to a failure mode. So this is the point where it's so expensive to fix it. And that is why predictive maintenance comes in. We have something called scheduled maintenance, and this could be very expensive. This could be also cheap, depends on the situation that your car is in. And that is what we are trying to predict. So we want to know exactly when is a good point to apply maintenance on your equipment, on your machine. And what is the benefit? We reduce the unwanted maintenance costs, and also we increase the production. And it's basically all about reducing the cost in the industry. The goal of predictive maintenance is to have a system, a prognostic system, which uses either model-based, where we simulate the equipment, or is data-driven based, which we as data scientists use the data to predict something. And this model should send us an early warning when does the model need maintenance action. There are some tasks that we could basically do in predictive maintenance. And two of the popular ones, I'm going to tell you what that is. So there's this period where your machine is healthy, it's running, there's no problem. And then there's this period where your machine makes weird sounds, but it's still in a good, acceptable quality. And then there's this period where it has difficulty to sometimes get started or not. And then, of course, there's this period where nobody wants to go in. The one that it's in the failure mode or the breakdown state, we could estimate how long do we have until that point, which is called time to failure estimation. And then there's another one where we could estimate this threshold until when I have an acceptable quality of production, I have an acceptable quality of my machine working normal, which is called remaining useful estimation. How do we solve these two? How do we do this task? We could do either with regression analysis. How long does my machine have until it is still in an acceptable quality, or how long does my machine have until it goes to a breakdown state? We could also do classification, where we say which state is my machine in? What sort of a state? Is it in the healthy, or is it in the breakdown? Is it in the failure mode? And these are the ways that we could solve these two tasks. So how do we apply interpretability into it? We basically have our car, we install some sensors on it to get some data from it. Depending on the equipment we have, we could get different sort of data, such as vibration, voltage, heat, and we analyze the data. We build a predictive model on this data and predict when does the machine go to a failure point. Then we take this trained data, we look at the prediction, and we apply a one of the interpretable techniques on it. This is an example of line, where I looked at why the model says that we are at the failure mode. And what does it tell me? It's basically that at each time step, the value of a specific sensor or other sensor are falling below a specific threshold. So it gives me a range of equalities. And then I have to look at my data and see okay, so that is actually true. Or my model is actually not as robust as I thought because, I don't know, it basically is modeling the noises as well. And this is how I use these techniques for predictive maintenance. So to have a summary of the talk today, the goal of this research field is to have as accurate as possible explanations and also to have easy and comprehensible explanations. They shouldn't be very complicated to understand. And then there are some problems that, for example, they're very subjective and they're very domain specific. We cannot apply some of the techniques in some of the domains. As I said before, we have a little bit of a problem with interpreting time series with the existing approaches, because most of the approaches focus on computer vision, convolutional neural networks, for example, and text analysis. There's also another problem is that we do not know how to evaluate these systems. How do we say an explanation method is a good explanation method? They roughly group them into three. Either they could be application grounded, where you just take the domain expert to evaluate the systems for you, which is very expensive. Or you could just use normal participants with completely different backgrounds. Or functionality grounded, where you look at the mathematical complexity of those approaches and compare them with each other. These are the references I used for my talk today and some good reads that I want to point you to. There are many if you want to get into explainability, but I found them very complete and informative. And for predictive maintenance, if you are also interested, you could look at the PHM Society Prognostic Health Management. They have public data sets and many, many publications to introduce you to the field. Thank you very much for your attention, and I'm available for any questions.
Yeah. Thank you. Thank you for your talk. We have one question. Thank you, Anahit, for your talk. We have one question. It's you talked about model-specific and model-agnostic approaches.
Mm-hmm.
Are there attempts to reverse engineer machine learning models to gain information about how they work?
Yes, but that would be also very model-specific.
Can you name one example, maybe?
The specific name of the approach doesn't come to my mind, but there are some which they look at the, for example, they create a heat map for neural networks, or they look at the loss function and look at the backpropagation of how these models are trained to be able to explain those models. But I can actually add them into my references, and when you make the slides public, then you could have that with the name as well.
Thank you. We have another question.
Mm-hmm.
You talked about using machine learning for detecting fake news. Does this not bear a big risk to more or less censor different opinions?
Well, actually, this is not my expertise, but so far the results that we are getting are very unclear, because what the model is looking at sometimes it doesn't make any sense. The words that it's highlighting, it doesn't make sense to us, and it's also very, very subjective. What we, for example, for hate speech, what is considered as a hate, and what is considered as a normal evaluation or a normal comment or something. So that is all I can say actually about this at the moment.
Thank you. I think there's somebody writing in the chat. There's another question. can you give a brief overview about ethics in AI, as this topic is changing regularly?
A brief overview. You need ethics in AI because if you train a model and you cannot explain what the model is saying, you will end up having cases where you give a person very low credit, and it's maybe because the model was racist or maybe the model was sexist. And also there are some samples where the model was, again, very sexist because it was looking at the text where the text was very biased towards a specific gender and made the prediction based on that. So this is why we need to bring a transparency, and this is what we talk about ethics. And that's why the models need to be transparent to not have this injustice based on the prediction of the model.
Thank you. The slides will be online. Somebody asked in the chat if we can go back in the slides, but you're going to make the slides public.
Okay.
Okay. We're waiting for questions. What topics would you recommend for a master thesis regarding XAI?
I'm sorry, it's topic for the thesis?
For master thesis.
If you have it at AIT.
I guess.
Okay. Well, not now at least, but there will be definitely some coming because this is a very, very, it's getting very attention and it's getting very popular, and there are so many challenges we need to solve.
I think there are no more questions. So, reaching the end of the Q&A, I want to thank you very much for your presentation. And
thank you for having me.
For everybody who's watching, you at the end of the talks, you will get an opportunity to have a private talk with Anahit. So stay tuned. For our next talk, we will cover the topic of cloud-native databases and the design choices that we have to face. This talk will be held by Hannes, a software architect at Prodyna, and he focuses on enabling businesses becoming successful on their path of running software in the cloud. So I hope you enjoy.
Sorry, I have a little problem with sharing my screen because Zoom, even though
Jetzt kann man Sie hören.
Kann mich hören?
Ja, im Chat steht so.
Okay. Und dann Entschuldigung für die Unannehmlichkeiten und vielen Dank für die Vorrednerin, dass sie kurzzeitig eingesprungen ist. Mein Name ist Hannes Bösch, ich bin Software-Architekt bei der Firma Prodyno und wir sind Mitglied der Cloud Native Compute Foundation. Ich bekomme jetzt Feedback, dass man mich wieder nicht hört. Ja. Ist es aktuell immer noch so? Ja. Also ich bekomme jetzt hier Feedback auf Mo, dass ich nicht gehört werde. Ist das noch so oder kann ich weitermachen?
Also wir hören Sie, wir
Ja.
anderen im Zoom, aber ich weiß nicht, ob
Okay.
der Host hört. Hier steht ja,
Okay.
du wirst gehört.
Okay. Technical difficulties, yeah, in a modern area. So this is the drawback of not being on site. Yeah, so I started off as, I'm a software architect at Prodyno and we do a lot of cloud native business. So we are a member of the Cloud Native Compute Foundation, and the project I want to be talking about is a cloud native project, a truly cloud native technology, which is a database, so-called NewSQL database named Spanner. And the goal of today's talk is basically at the end, you should be knowing what NewSQL is and how it compares to NoSQL. And just in general, what we mean by horizontal scalability in the cloud on the persistence layer. I'm going to be talking about not just theoretical stuff, but we've been building one of the biggest transaction systems in Austria. And this started back in 2018. So this was a truly microservice architecture. So as you can see, it was built in the Google Cloud. It was having different services. They had to be highly scalable. They needed to be dealing with at least 1 million customers per day and up to several hundred requests per second. So it was the number one focus to have these, our services, our applications scalable. But we also wanted to have, we also had these non-functional requirements, which they build up. So we need to be highly available 24/7. There was basically no downtime. We needed to be very, very scalable. So we need to have dynamic load characteristics there. So when you think of customers that would join in the morning or in the evening, so we had peak loads where you have a lot of more requests. So our platform would have to deal with that kind of load. So you scale up and scale down to be most efficient. We also needed to be consistent, which means when one of these services was writing something to a database, so the other service would have to have this change to the database immediately. There was no consistency gap in between, so we really needed to have that always consistent, supported by transactions. And we also need to be a very high performant because we were embedded in many other systems as well. So, and we had a lot of different customers on the other side. So we need to be very high performant. So when you think of all these non-functional requirements building up in a cloud stack, what kind of database would you choose? I mean, if you think for it just for a second. And basically you have to have transactions, right? You should be compliant with SQL also, but you also need to be highly available. And that is something that probably leaves very limited choices. And you probably would end up with one of the usual suspects. So you would be having an Oracle database or some MySQL or Postgres or whatever. And you would be hoping that this thing is just powerful enough that it can scale with the demand that you have. But luckily, we had an architect back then who was a bit braver, I would say. And in hindsight, he was right. He introduced a completely new piece of technology, which was Cloud Spanner. And I would just go one step back and tell you a bit about how it was introduced at Google. So because Google started with the search business, right, in the 2000s, but then their business model shifted a bit. So they got more involved with ads. And these Google ads had completely different requirements regarding storage. So it needed to have these high consistency guarantees. So what did they do? They went away from their original storage model, which was more like a big table, how it's called, and they moved to MySQL databases. But the problem with this approach is, in the beginning, if you have like fewer requests, it's all fine. But then the number of customers grow, you make more business. So all you can do is basically you scale your database vertically, which means you add more storage to it, you add more memory to it, you add more database, more CPU to it. But no matter what you do, there is always a limit to this model of scaling. So at some point you reach the limit, and all you can do then is, in the case of a read, for example, that you simply replicate. So you have a read replica of the other database, for example, and then you would be serving potentially double the traffic, but you still have the problem, what happens with consistency now, because these can have syncing issues, right, in between. And it gets even worse if you also need to write a lot more, because for write, you always have the bottleneck. It always needs to be coordinated somewhere, and it needs to be replicated. So you end up probably having your customers knowing about all these different databases, and you shard your data. So which means you will have the customers on one database, and you might have the orders in the other database, and the clients of this database, they now read to like compensate those transactions, right? So if some storage process fails, the clients on themselves need to revert it, have to have compensating transactions and these kind of things. So it's really cumbersome, and it's not something that can easily be done. And this is also what Google realized. And so it was so cumbersome for them to do this resharding and scaling with these MySQL databases that they started an internal project. And this was the Spanner project. So instead of having a SQL interface on one node, they started to invent something, so a SQL interface on multiple nodes. So it should abstract away the complexity, which is behind these multi-node systems. So making it completely like as a black box for the client, what's happening between, and it should feel like the traditional databases. Also to satisfy the customers, which were very used to SQL and all the convenience that comes with it. So the project Spanner was born then back in 2007. So they released a paper, made it public, available in 2012, the technology behind. And nowadays, this Spanner technology backs up more than 200 Google services. So all the services you might know and deal with every day, like the Play Store, Google Drive, Gmail, and many more. So, and in 2017, they added like a public interface. So you can use it now as a managed service using a REST API or gRPC interface. And this is basically what we did for our project starting from 2018. So we have been talking about a lot of this terminology already, right? So we have been talking about consistency, availability, and partition tolerance. And I just want to, get this straight. The CAP theorem is kind of limited in a way, but it helps us to think a bit about the trade-off you make in a distributed system. So the CAP theorem states that out of these three properties, you can only choose two. So you can either be consistent in case you have a network, like in case something in the network happens, but then you might not be available, so you might not respond to your clients. The other option is that you lower this restriction on consistency, but in case of a network partition that happens, you might not be available. You might not return consistent results, which means you would return stale results. Spanner is always consistent. So this is like one of the main properties of it. So this is what we needed for our project. We needed to have a consistent system. And at the same time, Spanner is so highly available, so they provide a very high SLA that even the inventor of this CAP theorem states that actually it's kind of a CA system because it's that high. And this is why some people say it messes with the CAP theorem. And also, since we're talking about strong consistency, there is this opposing model you might know from all these NoSQL databases or most of the NoSQL databases, where you have weaker consistency guarantees. So just think of a football game, for example, that was ended. The final scores are written into a database. So then, you tell the leader, which all the rights goes through a leader, and this leader replicates the data to the followers. But there's, as you can see, there's a time gap in between. And then you might have on different parts of the globe, you might have different observers, and they might read different states on the data. So you might have Alice, you might have Bob. And while Alice at some point earlier already knows that Bayern won the Champions League, Bob is still not aware of it. And there you can think of certain scenarios where this is not a big problem, like news sites. It doesn't matter if it's just a few seconds later or something, but this might be a huge problem for sports betting, for example. And it also was a huge problem for us. So we could not go with one of those technologies. Instead, when you think of Spanner, it is the complete opposite. Spanner is like the only database, at least to my knowledge, who provides external consistency, so strong external consistency, which means no matter on what part of the globe you're accessing the database, you get a linear order of all the transactions that happen. So everyone will receive the same order of transactions. This sounds trivial when we think of it as a single node system like the traditional databases, but it's quite unique in that field of distributed databases. So this really helped us not thinking about the data. So it could grow as we wanted it to grow, but at the same time, yeah, you have a consistency model behind that, like basically is, yeah, you have no worries about. And of course, this happens across all replicas. So once it's stored, it's on all replicas. This is one of the preconditions that it's externally consistent. So, but what's behind this technology? What makes it so unique? And I have to rush over it a bit, but it's quite interesting. So the one thing is they re-implemented this kind of consensus protocol. And if you have a distributed system with many nodes, you need to have a consensus which data has to be stored and which data will not be stored. So the majority needs to agree on a state of the database. And this is what they basically did with their Paxos protocol. So this is something that also been used at Zookeeper, for example, but they completely re-implemented it to make it more efficient for their use case. The second thing, and this is probably the most important thing, they introduced the so-called true time API. So they have a notion of absolute time, which means all of their data centers are equipped with these GPS antennas, and they have atomic oscillators, which means they can limit the time skew. So all data centers basically have the exact same time. And this is what allows them to give them the global ordering of transaction. And to be more precise on this, so they actually have a time interval, which basically is an indication of this time skew that happened. So you can always ask if one transaction is already like persisted or gone, and with what certainty. Yeah? And if two transactions are being compared, the other one probably has to wait until this thing returns true, basically. So this is very unique, and I'm not aware that it is used anywhere else except for Google. And the third thing, what makes it that performant, that available, is that they run it only in their own data center. So Google is a managed service, the Google Spanner is a managed service. You can only use it like via public API. And it runs entirely on Google infrastructure. So it's high performance network. It's a lot of redundancy there. So they do a lot of homework so that this stuff is really efficient. But how does it work under the hood, right? So if you're familiar with working with normal databases, it really feels the same way as normal database, but it's a bit different. So most of these distributed systems have the property of having like a key value store semantics. So the key basically determines on which node you end up. So if you have this simple singer table, so the first two singers like might end up or might be dealt with the first server, whereas the next three singers are dealt from another server. And this so-called split boundaries, so basically the split where the distribution is arranged, this is entirely handled by Google. So you need to make wise decisions on how you distribute them, but basically this is all happening under the hood. You just need to be aware that you do this stuff efficiently so that you follow some best practices on it. And all of this data is then like 3 times replicated, so highly available, and you can be pretty sure that this data is never lost. So we did a lot of advertisement now, but actually, how does it feel in practice? And back then when we used it, it was pretty new. So it had some kind of bugs, especially on the user interface. And there are also some pitfalls that you should know about when you want to use it. Like the first we stumbled across was that you're limited with the number of mutations that you can make. So if you think of a row that you insert in a database, and this row has, I don't know, 5 columns, for example, then this would count as 5 mutations to the database. So you can imagine you're quite limited in how much you can do within one transaction. So if you want to do bulk loading, and this needs to happen transactionally, this is a bottleneck. Also, you cannot like just arbitrarily many, just mutate arbitrarily many stuff or update as much as you want. So there is this limitation on that side. And also like heavy input performance can heavily influence your overall query performance. So if you have a lot of bulk loading going on in the background of the database, this can influence what your customers feel on the other side if they do read requests, because this can delay the query operations. Spanner always tries to optimize the workload. Like if you have like some kind of hotspots, you see the customers 1 and 20 are accessed very much. So they might be shuffled to another Spanner server so that they will be, it's faster accessible. So it also does some fancy caching in behind. But this shuffling, if it's a lot, like you do bulk loading, this can also influence your performance. And this is also something we found out during implementation. So, and then you see these kind of characteristics, right? You see, you look at the database monitoring metrics, and then you see these very high CPU spikes. And these are the indication. So you're not recommended to like go beyond 65 to 70%, because if it's getting higher, you might suffer with your request latencies. And this is exactly what happened to us, and where we needed to find some ways around. Also something to consider, I mean, it has become much better, I checked it, but by the time we did the implementation, we had very little help from the online community. It's a very new piece of technology, and there were only very few results if you needed help. But the good thing is that most of the drivers are available as open source, so you can at least debug them and go into technical problems if there are some. Yeah. And finally, this is like the list of bugs we faced in production with Spanner. So one of my favorite ones was that we tried to find the right balance between write and read sessions, of course, because it should be more efficient to use the write sessions. But when we did that, each of our transactions was delayed for more than a second, which is the optimum, the quite opposite of what we wanted to achieve is a high performance database. So the solution to this, and this is still the case, we had to use read sessions for write operations, which is quite spooky in my sense. Yeah, and then also some stuff like the sessions expired after 30 days because the certificates expired, and this was nowhere documented. So suddenly our workload started failing. Also interesting thing is, so we had this like promotions and vouchers we needed to have time limited. So we used the current date function, which defaulted to LA time. So it was active only 8 hours after they should have been active, which means, we got some calls during the night. And finally, since I'm approaching end, we can sum it up with, Cloud Spanner, I think, is a great technology. It has some downsides you need to be aware of, but if you go back, it tries to mitigate for everything, for all the shortcomings that NoSQL tried to solve from traditional databases, right? So if you think back in the 60s and 70s, this consistency was very, very important, and the correctness, but the availability because of lacking of that, I would say of the Web 2.0 and the number of requests was not that important. And these traditional databases still have a hard time on scaling dynamically. So the NoSQL tried to cope with that by giving up on the strict scheme and the SQL language itself, and switching to this eventual consistency model. And as we've seen for many workloads, and still, if you go to what's happening now, or just take all the production loads out there, 70% still rely on relational databases. So SQL is still very popular, especially among developers. So most developers learn it at school as well. So there is now, we see this shift from NoSQL to this kind of NewSQL. And it's not only Cloud Spanner, there are plenty of technologies out there that can do, that basically have some kind of similar behavior. And if you go to the other cloud providers, for example, and you look at AWS or also Microsoft, they come up with similar solutions, probably not that scalable and sophisticated as the Spanner solution is, but with other properties. So if you think of DynamoDB, for example, it's not a relational interface, but also highly scalable and yeah, can deal with dynamic load. So it's basically this, I use it, a database as a service. Yeah. This is basically the references I've been used on. I've used for this presentation. They will also be made available to you. And this is basically this landscape of NewSQL that is available. And with that, I want to close the presentation. Thanks a lot for your patience, and I'm ready for your questions.
Thank you, Hannes, for your talk. We collected one question from the chat. It's how do you know SQL databases compared to conventional relational databases in terms of performance?
So the question is about if how the Spanner database or NewSQL databases in general compare to the traditional database. It's a very good one. Thanks a lot for this one, because I think I had a slide somewhere for this. Yeah, so if you do short-lived transactions, which means you go to an online shop, you ask for that particular customer, you get that customer object out of it, using the primary key of that customer, then this database is highly efficient. So I can just give you some numbers. We had calls going into our system. Then we had to do 4 database calls in a row, of course, optimized for the primary keys. And all of the calls together, including the response, took us 30 milliseconds. So you can imagine you're like 5 milliseconds for getting one entity out of the database if you're accessing it efficiently. And then, having said that, we compared the Spanner database also to traditional databases in terms of full table scans. And there the result was, yeah, to say it euphemistically, I think it was horrible, because of course it cannot do it efficiently if there is no index on it. And so there's always the trade-off for all of these kind of ad hoc queries where you don't know how the result that you want to query on the database. So where you don't know the access pattern up front, the traditional databases are, from my understanding, way more efficient. But if I know the access patterns, then Spanner can be way more performant than Oracle database can be on these specific workloads.
Thank you. We have another question. Are there any use cases where you would recommend against using a new SQL database?
Well, you have to know Spanner is not the only NewSQL database out there. So you can also have like CockroachDB, for example, and you can host that in your Kubernetes cluster and have it on premise as well. But having said that, for these NewSQL databases bring a lot more complexity. So at some point, it's much easier to use a traditional database if you don't expect your workloads or customer base to grow indefinitely, or if you don't expect to have very high dynamic load characteristics. So if that's not the case, then you might be better off using just a traditional database if it fits your use case, or even think out of the box with NoSQL databases like MongoDB, Cassandra, whatever. I would recommend NewSQL for your cloud applications. So where you have applications that are flexible, that are scalable, And you also want to have it backed up by a database that is scalable. And particularly for Spanner, you actually should use GCP, sorry. Because if you're in GCP already, it makes a lot of sense to use Spanner. If you're outside the GCP, it doesn't make so much sense because you introduce the uncertainty of the network to get there, and of course the latency to get to the Google network.
We have another question. How are new SQL databases suitable for cloud native apps?
Yeah, so NewSQL is, as always, a very broad term, but in the case of Spanner, for example, it's a fully managed service. What does it mean for you? So all you do is you have an API to access the database, right? So your data can, your application can be completely stateless, and you have a high performance backend you can rely on. And this high performance backend, as I stated out in the talk, is always consistent. So you can rely on it. If you even have like cloud functions or lambdas or whatever, and they are just going to the same sync, but this is always consistent, right? This is something that scales greatly. And if you need more, you just add more nodes. It's just a click of a button, then you get more nodes for serving your traffic. And this is why I think it's a perfect fit for cloud native applications. But you also need to be aware that this comes at a price tag. So the managed service always comes at a price tag.
Thank you. We got another question. Aren't there privacy concerns when we use those managed services? Is it possible to host those new SQL apps on premise?
Yeah, very good question. This was also one of the concerns from our customers, so the number one concern. To be GDPR compliant in the European Union, you need to host this stuff in the European Union. And Google has data centers all across the globe, and a lot of them are located in Europe. So some of them are Zurich, then Frankfurt, then you have Belgium, you have Netherlands. So you can choose the data centers in the European Union. So this was the number one concern, and Google guaranteed that they will not leave the data centers there. So if you believe that, I think, I think it's acceptable. At least it was acceptable for the governance of the company I was working for, and they were pretty strict on this. But just using Spanner is the one thing. There are other services that you use with the cloud that are located in the US. And if you use some kind of advanced features of the database, for example, you need to be very careful what you're doing. So some kind of audit logs, for example, whatever. Logging is one of the major concerns. They can end up on US servers. So you need to make yourself familiar with these kind of things in order to be sure.
Okay. I think we're done with questions for now. If anybody has any more questions, you can ask them later to Hannes. He will be there in the single session afterwards. But for now, I'm going to thank you very much for your presentation.
Thanks a lot. Ciao.
The next one is held by Roland, the CEO and Head of Strategy, Innovation and Product Management at Grassfish Marketing. He will give us a peek into the world of digital customer experience, and he's supporting technologies as more and more stores and shopping centers are becoming a digital experience. Enjoy.
Good evening and welcome to my presentation is Buying Bread at Digital Customer Experience. Thank you that I have the possibility to talk about this topic because this is the main topic of our company. So what Grassfish is doing is that we are helping customers, especially retailers, on their digital transformation path. And there is online retail, which is around 20% of the retail market, and the main part is bricks and mortar retail, so shops. People go to shops, they like shopping, and digital transformation is a big topic there, and this is where we help them. We are a small company with 50 employees based in Vienna, so we have also some team members in Switzerland and Germany, and we work mainly for large corporations like BMW, globally Porsche, Lidl, for banks, airports, for Hugo Boss and other fashion stores. And our business is helping them to become ready for the future. And why is this necessary? It's necessary because consumers have changed. And this change, is not the change to buying something online. So it's not that people want to buy online or not want to go in the shop. It's it's like this: the behavior of the people have changed because of the use of online and especially mobile. So what people are expecting now is that they can shop everywhere, that they have a voice. So, for example, that they can do ratings, that they have followers, that they show what they have bought, and they are, so everyone is publishing media, and this is something that is really changing the way how brands and retailers communicate to the people. And also another topic is that personalization is a big issue because people and consumers want to buy relevant products. So they want to have the feeling that the products are relevant to them. The difficulty for retailers is that all these expectations and behaviors are different for different generations. So compared to earlier days, the different generations like the boomers and the generation Z, the millennials and so on, they have all different expectations, they have different behaviors, and they're also connected to online and mobile in a different way and in a different degree. And especially, so the younger people have, they do a lot of mobile. With mobile, they have the different platforms, and they use their platforms as part of the journey to buy products. So if they want to buy a product, they talk to others, they get opinions, they look at ratings, they share their opinion, and the retailers have, or they are aware of this, and they have to become part of these communication channels. And this is a main necessity because what is different now compared to the 70s, 50 years ago, is that 50 years ago there was marketing and there was retail. Marketing was the part of the company that did advertisements, TV advertisements, radio advertisements, print advertisements, and then people went to the stores and bought the products in the stores. But the marketing in the stores was very poor at that time, and these departments were really separated. So there was these two steps: we advertise something and people sell something. And this has changed now, because now a typical customer journey looks like this. So people get attracted, they speak to friends, they look at the websites, they search for other products, they compare products, compare prices, they go to the shop, and it's a long way from getting attraction to buying a product. And this long way has a large number of touch points: mobile, online, and also in the store. And all this has to be brought together. And there are a number of different buzzwords, say it like this, but these are different topics that have to be addressed through this customer journey. It's gamification, having fun, getting the right experience. People want to have incentives when they buy something. Personalization, as I told, is a big issue. And this has to be brought to the customers on all channels. And it started, so 50 years ago, there was a single channel, there was a store, and the customer went to the store to buy something. He bought it there and then went home with the good that he bought. And when online started, multi-channel was set up. So that means that companies, they had their stores, and then they had a different department, and a different department set up a web store. So you could, as a customer, buy products in the web store, or you could buy them in the store, in a real store. And but these were really separated silos because sometimes they had different products with different pricing. They had different messages. The main thing that was similar or the same was the brand, but everything below that was separated. And the next step was then cross-channel. That meant that a customer can buy things online, or they can buy it in a shop, but these were different departments, and also the data was split up. And what the trend is now, and this is really a large or big step for the companies, is omnichannel. Because omnichannel means that you have a consistent communication to the customer on all channels, meaning you have the same products, you have the same campaigns, and if a customer logs in on the web, then he should have the same bonus packages and the same vouchers and the same benefits as if he goes to the store. And if, for example, a customer in car retail starts to configure a car, then it should be possible that he goes to the car retailer, to the car dealer shop, and then calls up his configuration there and continues it there. So it's very difficult to set up this consistent journey with the same data, with the same media files, with the same messages on all channels. But this is a necessity because on the lower chart, you see that, and this is a little bit an older chart, a few years ago, that the customer journey can start mobile or in the web or in the store, and then and then it can finish somewhere else. So customers go to the web and then buy it in the store, or they go to the store and see things and buy it on the web. And the trend is that that this mix is really increasing, so that stores are becoming more like something like a marketing touch point, a flagship store sort of thing, where people can experience products, and but more and more people are buying then these products offline, online, in the web or mobile, but it can also be the other way around. And that's why it is really necessary that you have this consistent message and the consistent application on all channels. And this is really difficult for traditional companies, because for a company like Amazon, it's easy because they have set up their IT system 20 years ago or 25 years ago, and they started with a consistent system where the customer is in the middle, so a customer-centric system, and and it's only one system. So there's one big system, which is the customer relationship management system, holds the products, does the ERP and everything. The problem for a traditional retailer like BMW or Hugo Boss or Rewe is that that they have this old or this legacy IT system. So they started with they have an ERP system that holds the prices and the product information, but this system does not have, for example, pictures of the products. And then they have a media system, a digital asset management system, which holds the media files, but maybe without a connection to the products and the customers. And then some have a CRM system and some not. And it's very difficult for them to bring all this together and to create a consistent message. And this is their main problem compared to online companies, And it's not that the people buy online, but the people have the consumers have a different expectation how they can be approached. And for example, if we go back to the bakery, and the bakery is not a technical, or bread is not a technical product, and also not a luxury product. So it's a low-level product. But even here, we have a lot of different digital touch points. So one important thing is creating trust and emotions. So storytelling is one thing. Storytelling is important now because people do not buy products they do not buy products because they are cheap or something or expensive, but they buy products because there's a story behind. And this is, for example, if you live in Vienna, you know, for example, Josef Brot. And Josef Brot, they created, this brand created a story behind baking bread. So how you work with bread, with which ingredients you have, what is the philosophy behind, and it is necessary, or it is important to bring this story to the people. That's part of marketing. And one important aspect is also to bring this story and the emotional feeling of the brand to the people in the store. One part is always the store interior, but more and more brands use screens, or for example, digital menu boards to promote the products, but to also bring the brand and the emotions behind the brand to life, because it's always easier if you see something moving. For example, if you see a movie from the back office or from the factory where the bread is manufactured, then it's easier to get this feeling what is happening in reality. And so movies, which are easy to transport and to communicate on a mobile phone or in the web, are much more difficult to transport in the store. And screens and digital screens are a big part of or a big technology to bring this animated digital information to the customers. And a screen looks very easy to set up. It's a screen and then a DVD player. But in fact, if you are a manufacturer, a brand, you have a network of screens, and then you have a large set of messages and movies and menu board items and prices and products. So you need a strong content management system behind to connect all these dots to create the right messages, and to also create the right messages for each touch point, for each, because for example, if you have a shop in the city center, then it might have different products and maybe also different prices than a shop on the countryside. Then you have maybe different audience, so the consumers have different needs in the morning or at lunchtime. At lunchtime, for example, you sell more small lunch packets. In the evening, someone wants to buy bread for their home. So the products are different, the promotions have to be different, and this is an important thing for a dynamic system, that this dynamic selection of the content and the dynamic creation of the content is possible. And it goes into the direction that with, for example, camera-based system or with interactive system, the CMS gets information about the needs of customers in a store automatically, and automatically sets up the right messages. For example, we are working with some companies that have AI-based audience recognition systems who recognize age and gender, and based on this information, the right content is selected. But we are going more into the direction that based on the, for example, use of interactive applications, the interest of the audience is automatically selected, and in real time, the right messages are set up. So if you see a screen somewhere, and most people do not think much about it, in fact, there is a lot of IT knowledge behind of monitoring capabilities, stability capabilities, content management, artificial intelligence, and so on. The next step, which is important, is customer involvement. Customer involvement means that compared to a standard screen, which is a one-way communication, you want to bring the customer in the communication. So the customer should be part of the communication. This can happen online. For example, online you can have your website, you can do ratings, you maybe have a newsletter as a retailer. So you can create an interaction, but you can also do it online. These are two examples of from real projects of ours. So one thing is for example an ingredients screen. So ingredients and allergens are and vegetarian, vegan, healthy products is a big topic, and it is important for people to see what are the ingredients in a product, and especially also with bread and the different types of baked goods. It's not so easy to see what is inside, and so to find here the right product, so maybe based on an allergy you have, that's something where an interactive system can help, because usually or very often the sales staff in a bakery chain does not know everything about the products. And here an interactive system can help, and helps customers to find the right products. And then other important thing, especially with bakery products, is real-time information, because everyone knows it. If bread is freshly baking, then it's much better. So if you have a real-time information that in 3 minutes the kipfeln are ready, then maybe you wait for 3 minutes and get your fresh kipfel. So this is a connection then between the oven and the screen system to get real-time information and bring this information to the consumers. Other topics are personalization, so that you get that you have also can set up this personal link to the brand. So with loyalty cards that are now often used on mobile phones, and with the mobile phones you can then have your personal mobile voucher, so that you get your personal recommendations, maybe some vouchers where you can get things for free on the mobile phone, to create this connection with the brand, with the bakery, and bring also some rewards to you if you buy there. This is also one thing where you have then the CRM system behind, you have then the apps behind, and also some decision-making systems to define what is the next best product for a customer. And this is also important, brings me to the next important topic, to convenience, which is also becoming more and more important depending on the age of the generation. So mobile payment is an important thing that it's similar to other payment systems, but also online order and delivery. This is depends on the country. So for example, in UK, where we also have customers, real estate is very expensive. So it is more and more difficult there for grocery stores and supermarkets to buy or to have a store in on every corner. And this leads to this, that people often have to drive a long way or walk a long way to the next store. So online delivery and online order of food, something that is growing, for example, very fast in UK. It's not a big trend here until now, but this can change. But this can, another possibility here is, because this is, everything here is called live situation support. So one live situation can be that it is too long for you to walk to the store, but on the right side you see click and collect. And this is something that is for bread. has its importance, because if you, for example, after your work go to the bakery and you want to buy your favorite bread, then it can be like this, that it's out of stock. And with click and collect, it means that you can pre-order things. Like in the earlier days when you work, or maybe at some bakery stores, you can do it now, that you call them or that you are there very frequently, and they know which bread you want to have, and they store it for you. But the trend goes to this, that you have that you can reservice or order it online, but it is not brought to you, but you collect it on your way home. And the bakery cafe is then also something, a trend, that in the bakery that you not only buy their bread, but you can also drink their coffee or eat something. And this is also often accompanied with the use of mobile phones, that you have a Wi-Fi spot there, that you have screens there with news and weather information and so on. So you see there are a lot of digital touch points that are even important for a bakery chain. And behind this, you have large databases, you have the content management system, customer relation management, the media databases. You have big data, because all this data is collected, has to be analyzed. You have artificial intelligence algorithms to find the right products for the people. And then you have the different software pieces also on the screens, because the screen has a media PC behind, on the tablets, on the mobile apps, the IoT connection to things like the oven or to sensors. And so this is a very complex system behind to make this easy looking customer journey work on a digital way. And we do it like this, that we have a large number, or a large diversity of people here at the office. So we have hardcore backend developers, we have big data, especially mobile app developers, web developers, then our developers who do IoT and the software for devices. But these, the IT people work closely together with graphics artists, UX designers, with retail consultants to set up the right approach, because this topic is a connection of creativity and IT. That's also difficult often for the customers, because it's marketing and IT combined, or creativity and IT combined. And if we then do a project, then the people for this project are set up. So we create squads of people from different areas working together. And this is the main part, or the main reason for our success, that we have these people from very different backgrounds, creative people, graphics artists, big data analysts, and software developers of all flavors working together, creating this easy looking experience for the customer. Thank you. Yeah, it's the end of my presentation. Are there any questions?
Thank you for your presentation. We gathered some questions. The first one is, you brought up gamification in your buzzwords. Are there some examples how this is implemented in the customer journey?
Yes, there is. So gamification is important, because it does not always mean that there is a game behind. Sometimes there are games, for example, games where you then can win something. But gamification means the way, for example, for interactive applications, but also for the graphics, how they work. So it's like this, that if you work with something, with an app or with an interactive application on a screen, that it should make fun. It should yeah, it should make fun. So it is, or it should be a little bit like a game.
Okay, the next one is, how did the pandemic affect you and your customers? What were the challenges and maybe possible new opportunities?
Yeah. So for the pandemic did not affect us. In fact, during the last few months, we hired 8 people because digital is not is more a solution for pandemic problems. Because, for example, if you can pay contactless or yeah, or order something online, then it helps in pandemic times. And but we saw effects on some of our customers. For example, business of the fashion business and also transportation business was really affected, and everything what has to do with tourism. But for example, food retail, yeah, was very strong in the last month, and so it's it leveled out, but it did not really affect our business. What we did, we developed some new products or solutions. For example, we created a product that counts people in a store, and then you have a green and red light if you can get in or not. Or for example, we also have developed a product with a partner in the AI field, which can detect if you wear a mask or not. And if you then enter a store and you do not wear a mask, then there's a screen telling you, please put on your mask.
It's very interesting. The next question is, how are you conducting user research?
So user research is something what we usually do not do ourselves. So what we do is that we are working closely together with the customers. So it's not like this that we are only a software manufacturer. We are in the core, or in our heart, we are a tech company and we develop software. But when we speak to customers, then we are a companion, and we help them in setting up the right solutions. And because the digitalization of everything what is bricks and mortar, so in a store, is new for everyone, also for the retailers. We create solutions together, so we suggest new solutions and then we test them, or our customers, the retailers, test these solutions. And we see, for example, it's the best or the easiest way is with interactive application, where we can track how application is used. And but it's not only like this. So sometimes cameras are used to check if people are looking on screens or not, and how long they look at the screens to see what is interesting for them or not. Then sometimes our customers do customer surveys, and also what the retailers have, they have they see what is then in the end is which what products are sold. So user research is done on different levels, but always in a real project with our customers. And this is sometimes difficult, because very often it's like this, that we cannot share this information, because this information then belongs to one customer only. But for example, we set up 6 years ago shops for a Finnish telecom company with around 100 screens in the store and digital price tags. So it's really full of digital things, and this was tested over half a year. And then the result was that they had 30% more turnover in this store compared to other stores where they only had 10% increase. And then they decided, based on this information, to roll the solution out to all their stores. But so usually there are metrics behind, but usually they are the property of the retailer.
Thank you. The next question would be, what are your thoughts on lifestyle marketing like Red Bull, where the brand is more present in some kind of sponsoring than actually in real commercials? How does this affect the customer journey?
What Red Bull is a perfect example for storytelling. So one of my first topics, because what Red Bull really did very well is setting up the story behind the brand. I don't think that there are a lot of people buying Red Bull because of the taste. So the taste is, for me, it's good. I like Red Bull. I like the taste, but that's not. But the taste only, or the effect is not really the source of their success. The success came from the story behind, from the marketing, where they in the beginning especially sponsored all the extreme sports, and they were the only one that really were focused on extreme sports and everything around this, and created this cool emotion about the brand, and this is the root of the success, and it's not the product. So that's a perfect example where not the product is in the is the success. Yeah, that where the success doesn't come from the product, but really only from the story that was set up. And usually, and this is yeah, Red Bull does not have their own stores, but we have other customers who have their own stores, and they use the same principles, but not all companies are so good as Red Bull in this.
Unfortunately, there is no more time for further questions, but in case you have any more questions, you can ask them later during the single sessions. Thank you very much for your talk, Roland. Talk, which is by Volker. Volker worked his way from a sales trainee to SAP CTO for Central and Eastern Europe. He's taking care of 16 countries and is responsible to lead the newest technologies, products, and topics from incubation to commercial success. He will show us how data is changing the world and how to be successful with it. Enjoy the talk.
Super, okay. So thank you very much and welcome to my session. This is about how we can change the world using data. And I want to kick this off with a very simple question. And the question that I'm having is, if you were to found a startup right now, what would you found? And I will leave you a little bit with this question and a little bit of time to think about this. And I want to draw your attention a little bit about what is happening at the moment to this world, that you can make a better and more informed decision. Because what is happening, and this is happening more or less since the 60s, so Gordon Moore came up with this, what is now called the Moore's Law in the 1960s. And what it essentially says is that computing power doubles every second year, and that it's cost decreasing every second year as well. So he laid out a theory for, in the end, the exponential growth of computing technology and the data growth that we are experiencing and having in this world at the moment. And while technology capabilities are increasing with this exponential growth and costs are decreasing with this exponential growth, this explains a lot of what is happening right now in this world. This explains a lot about the technological developments that we can see all over the world happening. Like, for example, remote medical operations, for example, 5G, for example, autonomous driving, all of those technical achievements that we are facing now that are really changing the way how we act as a society, how we work, how we live, how we will do our jobs in the future, they are all based on the exponential growth of technology. And to put this a little bit into perspective about the numbers that we are talking about, so there's a recent IDC study out there that estimates that in 2025, we will reach a global data volume of 175 zettabyte. Zettabyte is a number with 23 zeros, or 175 billion terabyte. And this would mean if you would press this on DVDs, it would reach from the Earth to the moon 23 times forth and back. Or if you would watch, for example, the whole Netflix library 500 million times, that would be the equivalent. And to put this into perspective, in 2018, we had 33 zettabytes of data flying around the world. And after all what we know from the exponential growth, after all the theories that are putting in place, and even the reality is scrolling faster and faster than those theories, all what we know, and after all what we know, even this number will be too small in the future. And when we're reaching this number in 2025, almost 60% of this data will be corporate related. So at the moment, 60% of the data 2020 is privately related. So Facebook, Instagram, YouTube, stuff like this. And 2025, the estimation is that companies will generate way more data than we're actually doing in our private lives. And to put this a little bit into perspective about the data which is flying around at the moment, like while I'm talking, every minute in 2020, they are uploading 500 hours of YouTube video. While I'm talking, every minute, Amazon is sending out almost 7,000 packages, almost more than 200,000 participants in Zoom meetings, and there will be published more than 350,000 Instagram stories in every minute that I'm talking now. And this data is huge. And this data gives us actually the power of really changing something within the world, because data in the end is power, and data enables in the end totally new business models where we have seen a rise in the last, 10, 15, 20 years. So all the companies out there that are now big, like for example, Alibaba, Tencent, Amazon, Netflix, Google, all those big companies, SAP, for example, they are all tech companies. And the business models they are operating are all based on data. So if we look, for example, on the business model of Amazon, the whole business model of Amazon is based on data. The success of Amazon is based on the customer experience that you are having with Amazon, based on the fast delivery, the personalization, and the understanding of your customer behavior within the platform. And what Amazon is striving for in the end, or the vision, is that they can predict in the end your buying behavior. So what they're trying to do, like by combining all the data, or what they could do by combining all the data, is, for example, to predict what are you likely to buy, and to bring it then to a warehouse near to you, that if you are buying it, it can be delivered as fast as possible to your home. And then increasing the customer loyalty to the platform, because you get a good customer experience with Amazon. What they could also introduce based on the data, and this might come in a few years, also not just for Amazon, but for all platforms out there in this world, is a different pricing for different people. So what they could do based on the profiles they're having of you and based on the data they are having about you, for example, your income data, your social media profiles, the LinkedIn profile, where you're stating, okay, what job are you running for, which company are you working for, and which city do you live? which area in the city are you living in. They could actually show you up different pricing for different articles. So if you're living, for example, in Berlin, you have to pay a specific amount of money for a specific product, and somebody who's living in Schwerin, for example, they would pay, for example, less for even the same product based on the profile, on your personality, and based on the predictions that Amazon is making in regards to, can somebody pay actually this amount of money for this product? Another thing that I want to show you, and this is an official advertisement from iRobot, so those automatic cleaning machines that are running through your house and try to clean up your house. So this is something that you can actually find on YouTube. When you type in iRobot advertisement, this is a video that will show up. And what it's telling you is, or what it's showing is actually what iRobot is doing with your home. They have sensors in there, and those sensors are working in 2D. And they are planning out your whole home because they need to organize themselves. And they introduce a new feature that you can see here for the newest generation. It doesn't just have 2D sensors, but it's actually having 3D sensor built in. So what they could do in the future, based on the data that they are now generating, is that they are understanding exactly not just how big your home is, but actually which furniture is standing in your home. Like, how big is your carpet? How big is your couch? How big is your kitchen? And what they could do with this data, for sure, anonymized, but what they could do is to sell this data, for example, to furniture companies who want to better understand what sizes of homes do customers have and how do they combine specific furniture with each other. So this is really, data is really enabling new business models here. Now think about this. Whenever you want to renovate a wall in your home, you're going to one of those hardware stores like Obi or Hornbach or Bauhaus or whatever you have in your city. So you're going there, and then you have this huge wall about those 2,000 colors where you can pick one, and then you're buying this color, you put this on the wall, and 2 weeks later you're questioning yourself, man, why did I buy this color? It is ugly. So, and there's a solution for this. So the Technical University of Eindhoven is researching especially in nanoparticles. And they came up with an idea of having nanoparticles as a wall paint. So what they are doing is, or what you would do as a color producer is, you would not just produce those 2,000 colors anymore, but you would produce just one color. And you wouldn't sell it to the hardware stores, like, for example, Obi or Hornbach and so on, but you would sell it directly to your end customer. And you can control this color by your smartphone, for example, and you can control within your home on which wall, in which respect, should show up which color. And what's happening then here is that you're actually getting insights about the consumer behavior or the customer behavior in regards to your specific products. So insights that you weren't having before. So now imagine you would open this up and would buy in data from the outside, like, for example, Spotify data and other data. And what you could figure out, for example, is pattern in the behavior of people. Like, for example, somebody is coming home, the wall is blue, he listens to sad music on Spotify. So why don't you offer a service telling those people, hey, look, paint your wall red and listen to this and that music on Spotify, and your well-being will be better. And you can sell this opportunity to artists who wants to trend on Spotify. So instead of just saying random artists, what you can actually sell is the placements of those artists within your controller app. And from there on, you're changing your whole business model from just producing colors to platform business on Spotify. And this leads us into an area where you really have to question the ethical use of data. So is it ethical for a company like this to combine these different data sets and to find patterns in the behavior of humans, in the psychology of humans? And there's a very prominent example out there in the market. This is Alexander Nix. He's the former CEO of Cambridge Analytica, a company where I think they did a very, very interesting project. What they actually did is they gathered data from social media. They combined this data with psychological profiles and then did micro-targeting for political campaigns on social media. Because what they try to understand is what is the best political message for those specific people based on what they are sharing within social media and based on the psychological profile you can derive from what they are doing on social media. And this is from an ethical standpoint, highly questionable. And it's the same, like, for example, when you watch the Netflix documentation, the social dilemma, what Pinterest, Instagram, Facebook, what all those social media are doing to us, how they set up systems to actually changing the way how we work as a society. And behind this is one single concept, which is data as a business. They know, and all those companies know, and almost all companies in the world know that if you can generate data, you can make money out of this. Like the sentence, data is becoming the new oil, is around in the world like 15, 20 years. But the major thing about this is, and companies know this, they are gathering all this data, but it's unstructured data. Most companies do not know what they've actually stored in regards to the data and which hidden secrets are within the data sets they are actually gathering from all over the world. So the magic behind this can be for you to actually unlock this potential of and unlock the value of data which is stored. So making the data applicable, making data visible, run insights on data, and really generating insights that you haven't had before, and making sense out of data. And with this, you can influence actually the business world. So coming back to the questions, if you were to found a startup right now, what would it be? And you can tell me also this later on in the Zoom session that we are having, and I will tell you what I would found. So first of all, what I actually found last week is a company to sell innovation and to pitch innovation within Europe. So really helping others to pitch their idea to really bring disruption forward. The second thing that I was thinking of if I would have to found a startup is a fully automated cannabis farm running totally on machine learning. And I will tell you also later on why I'm thinking this is a great idea. And the third thing that I would think about if I would have to found a startup is actually a data startup, probably something with data intelligence or machine learning. So if we take the later on, if we take the data startup, and you would say, okay, this is something I want to go into as well. What could you actually do? So what you could do is, on the one side, generate new data. So putting like generating totally new streams of data, generating new insights that we haven't had before. Or the other thing that you could actually do is to combine different data sets and different data sources together in a new environment and put a nice user interface on it so that it's actually easier to consume and work with this data. And to be honest, 98% of all business models out there in this world which has to do with data are either falling in the category of generating data or either falling in the category of combining data. And this is exactly what's behind the success of Spotify, what's behind the success of Uber, of Netflix, and also on. Like the thing they were doing, it was established before Spotify, for example, existed. Listening to music already exists. This is nothing like, this wasn't a new category or something. The only way, or the only thing they changed was actually to bring this data together and put it into a different user experience, to put it in a different user interface, that it was easier for you to actually consume all of this data and actually giving you insights with machine learning and recommendations in regards to your personal taste, for example. A whole other category is, and this is then generating data, is what André Reterath did at the Technical University in Munich, or what he's actually doing. So André had an idea, and his idea was, what if I could predict the next Facebook or the Zoom or TikTok, so the next unicorn startup with machine learning? So what he did is he trained his machine learning algorithm with almost 80,000 startups and their development over 3 and 5 years, and then tested his machine learning algorithm against 111 venture capitalist investment professionals. And what he found out is that his machine learning algorithm outperformed the average venture capitalist professional by 29%. So almost 1/3 of the startups, André's machine learning algorithm could better predict if this startup would become successful in 3 to 5 years or not. So with this, you can really see that if you can understand data, if you put it into right context, it can really change the way how we can actually have an impact on the world and how the world is actually running. So data really enables new business models, and the impact of this is very enormous. And this is where SAP is coming into place, because this is the power of the company that I'm working for. Because almost 80% of all worldwide transactions are based or touched in an SAP system. So whenever you're driving a Mercedes, this is built with SAP software. Whenever you buy something in the Apple App Store, it's built on SAP software. If you buy something in Walmart or all the other retailers, it's run with SAP. If you buy Adidas shoes, it's made with SAP. So almost every company in this world and almost each and every transaction which is happening in the business world is running through our software. And with this, we have an enormous reach, an enormous impact on how to run a business. And the vision that we're putting out there for this responsibility is that we want to establish intelligent enterprises. And this means that running all transactions within this business environment, end-to-end, intelligence and automated. So what does this mean? What does those buzzwords mean? And what I'm always like comparing it to, or the analogy that I'm always using is kind of the autonomous driving for business processes. So you have your Tesla there, which is driving autonomous through the streets. And this is the software that we are supplying for businesses that they can run their transaction more or less automated. And with this, we have the huge opportunity to actually change this world. So what other people do on the streets, changing the world, we are actually doing in the conference rooms around the globe with the data of companies and to really help to change the way how they run the business. I want to show you 3 initiatives in the last 5 to 10 minutes that I'm having, how we actually running this and how we are actually doing this. So the first thing is around the networks. The world is changing, like companies depending on each other. Not a single company can provide a whole reach or the whole product anymore. So you have to have shared business models. Like NIO in China is now doing this. They are revolutionizing the electrification of cars by just selling a car, and then you get battery as a service from a partner where you can choose, depending on the plan that you are having, which battery you are actually trying to use. So this is very important. What we established here, for example, is a whole network for industrial 3D printing. So we brought together designers, customers, supplier, and delivery companies on one platform so they can interchange data, and that we very making the collaboration between those companies very easy on one platform. Another thing that we are doing right now, and this is something we published in September, is kind of the Amazon for B2B data trading between companies. So whenever you are a company, you're generating a huge amount of data. And sometimes it's the case that another company is highly interested in buying this data to get better understanding in regards to your industry or in regards to your business processes. And the problem with this is always the integration and the data clarification in this. So we build up a software for this so that companies can actually interchange data to each other to make the working together with each other way more easy and reduce the complexity. The second initiative that we are running, or one of those initiatives that we are running, is all about climate change. So we put out a project or whole program out there for Climate 21. And what we actually doing there is we supplying our companies or our customers with software that they can actually reduce their carbon footprint or their ecological footprint in general. So for example, we can track down for every individual product the company is producing its whole ecological footprint about the whole value chain. And this is absolutely unique in the market. At the moment, there's no other company in this world who can have this, this visibility about the whole value chain and to really track down the carbon footprint here. And the beauty of this is, if you're now knowing how much carbon footprint I'm producing, for example, based on my product, I can actually do something against this. So data allows decisions. And with this, we are actually establishing a whole new business category with our customers not just only having a bottom line and top line, but we're also introducing green line, because we're putting this out so that customers or end customers can actually decide, besides the price tag, reading also the carbon footprint, and then deciding with which company they are buying their products. And now I'm coming a little bit to this wheat farm thing, because we had a project with Farmers Cut, who is a startup from Hamburg, and they had the idea of doing farming in a totally different sense. So they are providing growth boxes, like you can see here, and it's called Harvest on Demand. So the idea behind this is not just you planting salad on the fields, but you're actually planting it at home or in your company. And whenever you need salad, you're just going there, you pick it from there, and then it's absolutely fresh. And the beauty of this company is that everything runs on machine learning. So whenever they deploy a growth box, and they are now deploying this to Kuwait and Dubai because they cannot grow salad there, it's all running based on a machine learning algorithm, which optimizes itself constantly. So they reduce the time to grow salad, I think, from 21 days to 18 days, which is huge. The third category we are working on is everything in regards to experience management, or how we call it, to really understand what is happening with your company and why is it happening. So why do customers actually buying, for example, your products, and why wouldn't they? Or why does somebody work for a specific company and why wouldn't they? What's the reason why you leave a company, for example? And then really in the customer journey or in the employee journey to figuring out, okay, what are those touch points? What is this real customer journey? And then measuring all those interactions and measuring what leads in the end to the fact that if you're walking into the store, you are walking out buying a product. And to really calculate this data and really put it into business context so that we can give our customers insights about how to run their business in a more efficient, more optimized way. But the thing behind this is always, you can have the best software out there. You can have the best code lines, you can have the best product, but if nobody is using it, it's totally useless. So when we are putting out software for Climate 21 to really tackle climate change, it doesn't have anything if companies do not apply this for their business processes. So what I have to do is I first of all have to develop the software, but then I'm also need to be able to sell the software and to kick off this whole innovation process. And I need to be able not just to coding it in the best way, but also to convince people to use the latest technology. Because in the end, the world has only been changed by people who changed it. So it's so important really to go out and actually trying to change some things. And this is what I want to encourage you to. So really to dare, whatever you do or what you intend to do. And coming back to the startup question in the beginning, whatever idea you would try to found, do it. Be bold, try it out, go out and try to develop your ideas. And if you need help in pitching those ideas or selling ideas to investors or customers, you can reach out to me. If you need help in your startup and try to understand how you can work with SAP together, what technology to use and how to run business models, how to run pricing, we have a whole world out there for startups within SAP. And if you want to go on the journey with us to really changing this world in conference rooms with the data of customers, you can come to us either, for example, as a developer or as a salesperson, and you should apply then for a job with SAP. My name was Volker Hein, and you can meet me now for questions and also later on in the discussion within our Zoom rooms. So thank you very much.
If you're still ready, we would have one question from the audience for right now.
For sure.
So the question is, almost every big corporation uses SAP in one way or another for some of its operational IT purposes. Isn't it dangerous when all of the big corporations are depending on one company?
I mean, no, it isn't. Because in the end, what we are providing is the best software in the world. So everything in regards to security, everything in regards to how we develop our software. So you have to imagine there are almost 100,000 people working within SAP, and almost half of them is development resources. And the thing why all of those companies are depending or using our software is because they are getting the most of our software, because it's the most highly sophisticated software out there in the market. It's not like that there are not other providers in the market. So for example, for all the different areas we are doing, like for example, procurement area, digital supply chain, manufacturing, the whole ERP market, customer experience, all those different categories that where we are providing software, you can always choose somebody else. There are always other vendors in the market who are providing software.
Back. About it, okay. So this was our last talk, and therefore we reached the end of this event. Lastly, we want to say thank you to the people who made this event possible, the speakers for sponsoring the event, to Career Center for sourcing the speakers and organizing the pitch audition, and HTU, which is the student union of TU Wien, and our volunteers of the Fachschaft für Wirtschaftsinformatik and Data Science, and of course you for watching and joining this event online. Don't forget that now there are the single sessions available, so we are posting the links right now into the YouTube chat, but if you want to join later, they're also going to be available on the website. So thank you very much for watching, and see you in the single sessions.